This is Note-Taking Guide 1.7 for Math 1. Today we're going to talk about graphing equations on a coordinate axis or coordinate plane. So I'm going to teach you how to do it today by writing a t-table. So I have these worksheets kind of prepared for you so that you can just kind of put it in. Up here at the top is the equation that we're going to graph. This one happens to be an equation of a line. I can tell just by looking at it. You might not know yet, but we're going to teach how to figure those out later. But right now we're just going to substitute our x values in. Here's my x values along the side right here into my equation in order to find the y values. So if I have y equals x plus 2 and my x value is 3, then I would substitute the 3 in place of the x, and my y value is going to be 5 because 3 plus 2 is 5. So my ordered pair is I put 3 in and I get 5 out. So that's my first ordered pair. I'm going to do the same thing for the 1 now. I'm going to substitute the 1 in place of the x. So I'd have y equals x plus 2. That's going to be 1 plus 2. So that's going to be 3. So when I put 1 in, I get 3 out. So here's my second ordered pair to graph. The next x value is negative 1. So again, into the exact same equation, I'd have x plus 2. So I'm going to go negative 1 plus 2. Negative 1 plus 2 is a positive 1. So when I put negative 1 in, I get positive 1 out. The last one we're substituting in is negative 2. So I'm going to put y equals x plus 2 in place of the x. I'm going to put in negative 2. Negative 2 plus 2 is 0. So when I put in negative 2, my output is 0. That's kind of messy looking. And so these are my ordered pairs I'm going to graph. So my first ordered pair, 3, 5. I go over 3 and up 5. And that's where my first ordered pair is going to be. Then my next ordered pair, over 1, up 3. So right there. Over 1, down. Oh, I'm sorry, over 1, up 1. So negative 1, 1 is like right over here. Oh. See if I can get that back. Here it is. So negative 1, 1 means I go over to negative 1 and up 1. So I'm right here. And then I'm over negative 2 and up at 0, which is right there. My line goes through those ordered pairs. And I can tell that that's a line. All right, we have 3 more examples of the same kind of thing here. On this next one, I'm not going to show quite as much work in my boxes. I know I'm substituting into 3x minus 4. So I'm going to go 3 times 2, because it's my x value, minus 4. 3 times 2 is 6. 6 minus 4 is 2. I can just punch that in my calculator. So my ordered pair here is 2, 2, because I put 2 in, I got 2 out. This time I'm substituting in the number 1. So 3 times 1 minus 4. 3 times 1 is 3. 3 minus 4 is a negative 1. Again, you can just punch these in your calculator. So my ordered pair is I put 1 in, I got negative 1 out. So my ordered pair is 1, negative 1. Next thing I'm going to do is put in 0. So I'm going to do 3 times 0 minus 4. Well, 3 times 0 is 0. 0 minus 4 is just going to be a negative 4. So when I put 0 in, I get negative 4 out for my ordered pair. And then my last ordered pair here, it asked me to substitute negative 2 in for x. So 3 times negative 2 minus 4. 3 times negative 2 is a negative 6. Negative 6 minus 4 is a negative 10. So when I put in negative 2, I get out negative 10, which is going to be off my graph paper, but let's just graph this the best we can. So my first ordered pair is 2, 2, so I go over 2 and I go up 2, and my ordered pair is going to be right there. It's kind of messy. My next ordered pair is over 1, down 1, so over 1, down 1, so I'm right here. My next ordered pair is 0, 4, so, or I'm sorry, 0, negative 4, so 0, negative 4 is right here. And then negative 2, negative 10 is going to be clear down here somewhere. But this is going to make a straight line going through those ordered pairs. All right, this next one, I can actually tell it's exponential because look at that right there. That power is up there. It's an exponent. So when I substitute in here, I'm actually going to do powers. Now these numbers are going to be pretty big, so I'm probably just going to have to guess for the most part on this graph paper what it's going to look like. So I'm going to do 2 and then substitute that 5 in as a power. 2 to the 5th power is actually the number 32. So my ordered pair is 532, which is going to be way off that graph paper. My next one I'm substituting in is 3, so 2 to the 3rd power. That would be 2 times 2 times 2, which is the number 8. So I put 3 in, I get 8 out. The next one would be substituting in 0, so 2 to the 0 power. Anything to the 0 power is always equal to 1. That's a rule, so don't forget that rule. So my ordered pair is 0, 1. And then the last one, I put negative 2 in as my power. So I'd have 2 to the negative 2 power. And when you punch that in your calculator, it's going to tell you it's 1/4. So when you put negative 2 in, you get 1/4 out. Because negative powers always move you to the bottom of a fraction. So then we just have to graph these ordered pairs. So the first one, 532, it's clear off my graph up here somewhere, like clear off my graph. So we're just going to know that it's up there. The next one is 3, 8, which is still sort of off my graph. We'll just kind of put it right there somewhere. The next one, 0, 1, which is kind of right here. And then the last one, negative 2, 1/4. So negative 2 and 1/4 is like right here, just a little bit up. So my graph is coming clear up like this somehow. It's an exponential graph. It's growing really quickly. And that is going to be not linear. Clearly it's a curve for the graph of that function. All right, the last one here, here's my equation, negative 1/3 x minus 2. And I'm going to substitute in my numbers on the side here. So my first one to substitute in is 6. So I have a negative 1/3 times 6 minus 2. Just take a minute and plug that in your calculator. You'll go negative 1/3 times 6, which would be a negative 2. Negative 2 minus 2 is going to be a negative 4. So when you put 6 in, you get negative 4 out. The next one will be a negative 1/3 times 3 minus 2. So a negative 1/3 times 3 would be a negative 1. Negative 1 minus 2 would be a negative 3. So when you put 3 in, you get negative 3 out. Next ordered pair to put in is 0. I always love substituting in 0 because when we multiply by 0, we get 0. So all of that changes to 0, and I just have a negative 2 for my solution. So when I put 0 in, I get negative 2 out. And then the last one, a negative 1/3 times a negative 3 minus 2. This negative times the negative right there is going to make that positive. So positive 1/3 times 3 is going to be 1. 1 minus 2 is a negative 1. So my ordered pair is negative 3, negative 1. And then I'm just going to graph those ordered pairs on my coordinate plane here. So I'm over 6 and down 4 for my first one, which ends up being right here. I'm over 3 and down 3, which ends up right here. I'm over 0 and up 2. Oh, I forgot my negative when I wrote that down. Notice the negative right here. I'm like, that's not right. So I'm actually right here instead. That's always a good way to tell whether or not your graph is correct too. If an ordered pair seems way out of place, just double check your work and make sure you did it okay. And then our last ordered pair to graph is a negative 3, negative 1. So negative 3, negative 1, which is right here. This graph is linear. My graph goes through those ordered pairs. And that is the end of this note-taking guide. Thanks for watching, you guys, and good luck with your homework.